Hi, welcome to section 3, Network in the Modern Era. So previously, when I first started in the networking industry, we really kind of work in a silo. We build a network and everybody build on top of us, top of the network, and the network just works. But in the recent movement, we're seeing this trend of having the network moving toward what was previously perhaps not available to us because we work in such a silo and domain specific area where nowadays databases, CI/CDs, and continuous integration, code repository, and all these other tools that were previously available perhaps to the developer and system engineers, now it's available to network engineer as well. So we're moving toward this area. So in this section, we're going to take a look at using the SQL database to persist our device information. We're going to look at why use a database was useful, for backup, scaling, and so on. And we're going to look at just a few examples. Well, actually more than a few examples, trying to be as wide as possible using the NXOS, iOS XR, Arista, Juniper, Vieta, and we're going to look at the integrated example. I think it's really useful to start looking at the API interfaces for different vendors and kind of look at this trend. So I think the questions that I faced when I first wrote the book on Mastering Python Networking is that network engineers don't know where to get started, and that is really tricky because going from 0 to 1 is very difficult. You want to look at the first example and then build on that example, whereas developers would come to me and say they don't know how to get started with the first networking device. So that kind of having that 0 to 1 was this converge area where I think would be most beneficial to both network engineers as well as developers. And once you see that first example, you could expand on that, right? Like you get that first operation going now that you feel comfortable in exploring more. So let's get started. We're going to take a look at the database persistence for networking information. Hi, in this video, let's talk about using the database to store our device information. So first of all, why do we want to use the database? Because the database their whole job is actually to store information and make sure the information is consistent, it's stored safely. So therefore, it's better for scaling. I mean, everybody understands the importance of database of information. So, database has been around for such a long time that it's easier to scale with a dedicated place to store your information. Imagine if we have that, a file-based, information storage like we have before. Yeah, it's easy to get started, but what if you move beyond one server or two server or three servers that you're still having to replicate that file, and that file gets inconsistent throughout time. I guarantee you that it's not going to be the same on different, if you keep it in 3 different places, one of the places is going to get out of sync with the other 2. So having a centralized location to keep relationship if you use a relational database, and central location for scaling, backup, management, dedicated step, there's multiple benefits for it. So in this case, in our scenario, we're going to use a SQLite database, and that's for several reasons. One is that it's transparent to other SQL database. So once you use SQLite, if you use other Postgres or MySQL, then it's easier to transfer that to other bigger database. And the second reason will be that Python has a built-in connector. You don't have to download any connector like Postgres or MySQL. Perhaps you want to download more connectors, but Python in the standard library actually have a SQLite. And the third, that is file-based, so we don't need to install anything new. The database is simply just a file stored on the local system, but it's really easy to get started. So let's take a look at the example of the SQLite database. So here you've seen the window that we've had under the section 3, and we have several examples. So let's just launch onto the Python interpreter and take a look at how to use the SQLite database. So first of all, as mentioned before, SQLite 3 connector is already in the standard library. There's nothing new that you need to install. And the first thing that we want to do is we actually wanted to create a database, and this command actually creates a database called networks.db, and it automatically creates that and puts it into your local directory. And now we need to do a cursor to interact with that database. And this command actually creates a table in that database. And what you see in the doc string, like the triple quote, is that not the doc string, but just a multi-line string, is that this is a SQL command, and that essentially all the command is in capital, and all the nouns, the table name is devices, and these are the attributes that we put into that table. So the table will have a devices table, and in it we have two fields, two columns, basically the host name as well as the attribute. So now we've executed that, and let's put in two values within that table, and we're going to use the ag. So the first one is that, we're going to put in the New York City ag R1, and these attributes are what you've seen before in the previous examples, except those were the tours. Now we're using the ags. So now we're putting in the ag R1 as the host name as well as the tour R1 in there. And later on, this is by design because we're going to use a query example later on. And now you have to commit it to the database. And so you have this cursor, and then remember the connection is what you interact with the database with. And now let's close this connection. And then now exit this terminal. So if you take a look, now we have the network.db, networks.db. Previously, you see that when we list, there's no file. So this database is essentially what we have right here. And if you look at this, it's a little bit gibberish, but you could still see that essentially this is what we have put in. So let's take a look at how we could query for information. Let's launch the interpreter again, and let's import SQLite 3. And now we still need a connector, right? Connection to the database. So again, this is the local connection to network.db. Remember, last time it didn't exist, so we created one, but now it existed. We're just connecting to it. We still have the cursor, and now we describe what we want to query. And now we could just say, hey, select my table from devices table, and where the hostname equals to the ag R1. And now we have to print out the fetching, and now we have this tuple where the first item will be the hostname, and then the second will be all the attributes that we have for it. And we could also do multiple queries for multiple devices. Now we say, hey, select star, and these are all SQL languages and well documented. And if you have any questions, there's a ton of information out there where you could search by it. And now we just say, hey, we're querying all devices, and we're going to order by host name. So now we could take a look at those. And now we see we have the both devices. And this is obviously very interesting because now we have the iOS and NXOS. Previously, we just specify a very specific search by hostname, and now the second search would be to query multiple devices. So let's close that connection, and then let's exit out. So again, this is just a file, so we could actually, if we messed up or something, we could just remove it. And I have actually created a SQLite create Python script, and you could take a look. That is essentially just what we've gone through before, but also I'm putting in all the values that we've seen in our two data center network, the tours, the ag, the course. So, you could just actually execute that. And voila, there's network.db. So let's look at network.db. And again, you could kind of make out that this is what we have done before. So that is our short demo for the database persistence. Again, this is more scalable. This is for better, backup and so on. But using the SQLite as a simple way to just get started.